Hi, my name is Julia Silge, and I am a data scientist and software engineer at Posit. And today in this screencast, we are going to use a recent Tidy Tuesday dataset on spam email, this is one of those classic machine learning applications that goes back to like the 90s or something like that. And we're going to specifically think about this spam email as if we were coming to it as a new modeling project. And we don't know what kind of specific model might be the best fit. And so we need an approach to try multiple of them to see what might work out best. In Tidy Models, the tool that is available to do this is called Workflow Sets. It deals with multiple combinations of feature engineering and modeling approaches. So we're going to use workflow sets to try out a number of different models to predict whether email is spam or not.
Okay, let's learn about spam email. Worst thing about email? I don't know, maybe. So this data set is, let's take a look at it. Medium size here, and we have a outcome over here, which is whether it is spam or not. So let's see what that looks like. So we don't have a lot of class imbalance. We have, it's not too uneven. And how many observations in this data set are spam versus not spam? Now, in a real application, if you were building a spam classifier, you almost certainly would have the text of the email, but that's not what this data set is like. This data set is more like a bunch of feature engineering has been done for us, and so we can concentrate more on the model estimation and not so much on feature engineering. So these are quantities that have been measured from email. So if here, this is the total length of capital characters. So like how much is like all caps yelling kind of words. These first three are kind of about characters. This is dollar signs. This is exclamation points. And then these last three are kind of more about words. Does it have the word money in it? Does it have the character string 000 in it? Does it have the word make in it? So these are think of these as features that have been engineered from the text. And so, we're not doing that here. We're not doing the feature engineering. We're only doing the model part. Okay, so let us do a little bit of understanding what this looks like. So for example, let's start with that first one, the number of characters that are capital, that are like all by each other. And let's make a density plot so we can see how this is distributed. So really long tail. So let us put that scale, that x-axis on the log scale like that. And let us look for a difference between our spam and not spam. So if we say fill equals yes, no, like that, and something like this here, and let's see what this looks like. Okay, this is a lot more clear. We can see what's going on here. So on the x-axis, this is this number of consecutive capital characters. And we see that for the spam email, this is shifted to larger values compared to the not spam email, which is shifted to lower that variable. So these are the kind of differences that we will use to take advantage of in building a model. Let's look at the rest of those features that have been made for us. So let's pivot longer. So dollar through to make. Pivot longer here, so we can make a visualization for all of these at one time. And I notice that there's a lot of zeros in these, like many emails don't have the dollar sign at all. So for a visualization here, I think this will just be easier if we say, maybe compare like 0 versus not 0. And I think also let's replace that with some text. So when it's true, then it is greater than 0. if it is false, it is 0. And actually, I can just make it like that. Nice. Okay. 0. Let's also, for visualization, that y and maybe would be more clear a different way. So I'll just do something similar here. But yes, no, if, else, yes, no. When it's no, that is not spam, and else it is spam, like this. Okay, I think this will be better for making a visualization. So let's put the value there is what we're gonna visualize. Let's do fill equals yes, no, and then facet wrap with the different features, the name there. I forgot to put anything on my plot. Okay, so let's, I think if I do bar, notice that here the default is stat equals count. So that will count these up for me, which I think is what I want. Nice. Okay, this is good. I like this. So we're seeing columns that are the counts, and we can compare across these quantities. So when the columns are really uneven within one, that means that a lot more email have 0 examples of the word money compared to 1 or more. Over here in this bang, so that's the exclamation point. They're kind of even, so that means there's the emails are about even between those that have 0 exclamation points and that have some. So exclamation points more common than the word money. And then when we compare one bar to the other bar, the differences here tell us how that is distributed between things that are not spam and spam. So if we look at the explanation points, the greater than 0, lots of spam compared to the 0. So explanation points, the difference here is significant. And so that's what we're being able to use when we make our model. All right, great. So we have done some exploratory data analysis. So let's start now with our models. I'm going to load the Tidy Models meta package. Then I'm going to take that spam and I am going to, make that, the outcome a factor. Like that. Because that will be my outcome, the thing that I'm going to use to do a prediction. So let's call that spam split. So first thing I do is I will split my data into training and testing here. I'm going to use stratified resampling. Just, it hardly ever hurts you to do that. And this was pretty even, so not, it's not hugely important, but let's call this spam train. So this will be the training data. Let's say spam test. This will be the testing data. So what I've done so far here is take my data, split it into testing and training, and then I can also create some resampling folds. So I'm going to call it spam folds. I'll make cross-validation folds from the training data like this. All right, so this is the part of the modeling process where I am deciding how to spend my data budget. I have a certain amount of data that is available to me, and I'm dividing it into training and testing, then creating resampling folds so that I can compare and choose and tune models. All right, so like I said before, a lot of feature engineering has been done for me. So I'm not going to really worry about that too much. These are all numeric. I don't even have to worry about making dummy or indicator variables. This is pretty much ready to go for most kind of models. But like I said in the intro, often when we start a new modeling process, we don't really have a good reason to choose one model over another, and we don't know which one will be best. So let us use this data set to walk through how to compare a number of different models, as you might when you are starting a new modeling process. So I am actually going to start with naive Bayes. Right, Descrim. So it's actually not in Parsnip. It is in one of the Parsnip add-on packages, Descrim. And let's call this NB spec, like this, naive Bayes. So the reason I'm choosing this is because this is actually like all the way back to the, I don't know, 90s or something, when spam email started to be a thing. Actually, naive Bayes classifiers were used for this. So let's, for old time's sake, let's include a naive Bayes. Naive Bayes only does classification, so that is ready to go. Let's do, which else should we do? Let's do a Mars model. Mars. This is multi-adaptive regression splines. Is that right? Multivariate adaptive regression splines. So this makes pretend features. It's like segmented regression kind of thing. So we've got this. Let's call this Mars spec. It is a good option in a lot of situations. Mars can, like it just said in the help, can do classification or regression. So we need to tell it what to do here. And then let's do a random forest RF spec. So we'll say random forest like this. And random forests tend to work well without tuning, as long as you make the trees high enough. Okay, so I just said that without tuning. So this reminds me actually that all of these models have hyperparameters here. We can, if we don't set them, it just uses defaults from the underlying modeling package, however. But we could try to eke out a little bit better performance by tuning them. So, and they all have this. So let's make a new spec here. So NB spec tune. And let's tune the first one. You know, this is, and then let's do the same thing here. Tune, and the Mars, let's tune, let's tune number of terms. Like this. And RF spec, let's go crazy and tune to, whoa, I know, big time. So let's see, let's put this on a new line. So let's say trees. The other two are mtry and min n, like this. Okay, so what we have here? We have 6 model specifications. 3 of them are untuned. 3 of them are tuned. These are models that you can, like try to find the best hyperparameter situation for these particular models. So let's see like how much different it makes in this particular situation. All right, so the next thing we do here now is we are going to make a workflow set here. So the first thing we say is a set of preprocessors, which for us is going to be very, very simple. We're not trying a bunch of different kinds of preprocessors. A lot of like feature engineering has pretty much already happened by the time we have this data. So we're just going to use a simple formula. We're not using a recipe or doing anything fancy. We're just saying predict whether it's spam or not using all of these predictors that are in this data set. By contrast, we are going to put a whole bunch of models in here. So we're going to make a named list here. So we're going to say naive Bayes, Mars, random forest, like this, and then we will add the same 3, but with the tunable versions of them. So okay. Great. So let's assign this to something, spam models, and like this. Okay, so we've got all these. Here are model specifications. Here are now our workflow sets. So notice this is a data frame that has in it 6 workflow IDs here. And we've got info on these here. So what we're doing is making combinations of preprocessors and models. In our case, we only have one model, but if you had 2 or 3, you would cross them so you get all the combinations. Or you don't have to cross them. You can make them just a one-to-one here. So now think of this as a whole set of different workflows of combinations of feature engineering and model estimation that we can now evaluate all together. So I am going to register a parallel backend here on my computer. I'm going to set a seed again, because these models like random forest and whatnot all use randomness. Like they can turn out slightly differently depending on where you start. So we're going to take these spam models and we are going to use the function workflow map. So the first thing we're piping in is the models, and the next thing is the function, which the default is toGrid, which is actually what we want. And then we need to pass in other things like the resamples, which for us are these folds. And then I would like, maybe this will be it. I'm going to do it. No, I'm doing it like this. Okay. And then the other thing I want to do is some non-default metrics, because I want the accuracy, but I also want the sensitivity and the specificity like that, because that will let me see how does it do on the spam versus the not spam, as opposed to only accuracy. So let us kick this off. Okay, so what's happening here? This is where the actual, like a whole bunch of model training is going on. So we have 6 models. 3 of them are tunable. So I think the default for each of those is 15. So we're doing 15 times 3, 45, plus 3 more. So roughly 50 models. And we are training those 50 models each 10 times. So where did the hold? So each of those 50 models is getting trained to this, evaluated on this, trained to this, evaluated on this, and so on and so forth. So 50 models times 10 times. So we just trained like 500 models or so. So this is a situation where you truly want to make sure you're using good statistical practices. I mean, what I did here is fine, but by the time you're trying 500 possible model configurations, you really need to make sure you are not going to be fooled by the kind of things that you're getting. So tidy models, of course, is set up to try to avoid you making mistakes. So let us look at the results. There's an autoplot method for workflow set results like this. So let's zoom in here. There's a lot of information in this plot. So let's look at it. Whoops. I want you to be bigger. Okay. All right, so we have our 3 metrics that we looked at: accuracy, sensitivity, and specificity. So first off, kind of notice where the y-axes are. The sensitivity for all the models is better than the specificity. So it's easier to recognize one class than the other. So I bet the positive class is probably N, because N comes before Y, and so that's the not spam. So it's easier to recognize the not spam than the spam. However, the models are not equal when it comes to how much difference is there. So for the naive Bayes model, it does the best on the not spam, but the worst on the spam. So specificity here is low for the naive Bayes model, which pushes since this is pretty even, the accuracy is pushed down. The one that does the best looks like it is the random forest, because it has the like a good specificity and good sensitivity. And you see that over reflected here in the accuracy, since this is a pretty even data set there. So these are the kind of things like we can look at, we can understand differences and how the models perform across the two classes, not only overall, but also how does it do for the two classes here. So that's it's looking like random forest is pretty good, but we had an untuned and a tuned random forest. So I'm pretty curious how this turned out. So if I say rank results spam res, I can say a rank metric. Let's say accuracy here. Oh gosh, this is so funny. Okay, look at which one is best. It's the untuned one. I mean, there's not much difference here. So this for the untuned random forest, the mean accuracy is 0.881. The next best one is 0.880. So these are very small differences. Like these are not big differences, but the untuned one had the best overall accuracy. If we wanted to get the best overall specificity, which in this case is the identifying the spam, we'd want to go to this one. It's the best. But again, these are not huge. These are not huge differences, especially when you look at the standard errors. So boy, random forest, you gotta love her. She's doing so good. No, so random forest is this is why we love random forest. Random forest is low maintenance when it comes to hyperparameters. Like, as long as you make sure it has enough trees, it does well. And it often does great. As here we notice it doing better than the naive Bayes and the Mars models. So let's say, yep, that's what we're doing. We're going for random forest, and in fact, we're just not even gonna tune it. So from our process of working through the workflow splits, let's say that's what we come out the other side and have decided to do. So let's make a final workflow. You can pull it out of here, but I'm just gonna remake it here because I think I am interested in like changing the engine args here. So I definitely still want Ranger like I had before, but I am going to pass in an engine argument, importance equals impurity, which means that as it trains all the trees, it is going to keep impurity information to help me understand which are the most important features. I'm going to do variable importance in this way. So let's call this spam workflow. And then I will do spam. Let's make something called spam fit. Let's do last fit. So last fit fits one time to the training data, evaluates one time on the testing data because we pass in the split here, like so. Okay, so let's fit this. So it fit to the training data, evaluated on the testing data. It fit it. The only thing that was difference between how it fit before is that it is computing variable importance as it goes along, which is something random forest can do. Okay, so we can collect the metrics and compare them before. Let's collect the predictions like this, and let us start by doing a confusion matrix. So we're going to say the first thing is the real answers, and then the second thing we put in here is pred class, like this. So this is a confusion matrix. It tells us in a little table form where do things fall in these 4 buckets. So notice here is the real not spam email. Lots and lots of those are predicted to be not spam. Only a few are incorrectly predicted. Notice that when it comes to spam email, a third, as much is over here in Y. So the spam email is harder to find than the not spam email. This is true even for the random forest, which did the best job of the 3 we tried, identifying spam email to be actually spam. So email that's really spam, we identify it as spam. Random forest did the best of all of them at that. Okay, so that is a confusion matrix. We could make a visualization, but let's keep going. Let's, we can do a ROC curve, which is often an important thing to understand about our model. So if we do ROC curve, so here we'll say yes, no, and then instead of predicted class, will be predicted the predicted probability. So if we say Y, that's for spam. That's the probability that spam. Oops, right, but spam was not our spam. Yes was not our base level. No was our base level. If you ever get a upside down ROC curve like this, it just means that you're using the wrong predicted probability. So that's what we want to see. We want it to be up in that corner. So this tells us at these different levels of thresholds how we do. And so the this is a model that compared so if we put the other models on here, they would be doing worse because they were not as good as at predicting the spam email. Okay, since I computed the variable of importance as I went along, let us go ahead and do that. So I can get out the fitted workflow from this little, remember that spam fits a little tibble here that has the split, it has metrics, it has a workflow. I can just pull out the workflow like this, and it is my fitted workflow. And if I want to do with the VIP package, it does not know, I think, about workflows still, but it does know about parsnip models. So I can get out the parsnip model and I can call VIP and get kind of a default visualization. There's lots more I could do here, but we just take like a quick glance. Looks like the exclamation points. They are the most important thing for the model, followed by the $sign, capital letters, and so forth on down. And so the one that makes the least difference is the word make, which I can understand that, right? Like, not spam email is it's very common for it to have the word make. The word make is a very common English word, so it's the least important here. Okay, so what have we done? We evaluated a lot of models. We decided which one we were going to go with. We fit it. We did some evaluation of how it was doing. And now let's finish up by saying we love this model and we want to deploy it. So we are going to use the Vetiver package to take some first steps towards deployment. So I'm going to do the same thing where I take out the fitted workflow in here, and then I am going to call Vetiver model here. I'm piping it to Vetiver model, and I am saying span email random forest. So this is a model name. This is like a name that I can give it that'll be used later in various aspects of it. Like this, like so. So this is a ranger classification. All this information is recorded for me right now, getting it ready to deploy. And this would be where I would go into a deployment kind of workflow, wherever it happens to need to go. I am going to show you, what that will kind of look like. This is not deployed, but it is setting up the API that would be deployed. So this would be how you might do local debugging for your API here. So what has popped out here for me is some interactive automatically created documentation for my model. So it has information about the metadata of this model. Here are all the packages that are needed wherever this is going to go. I have information about the prototype of this model, which is the input data prototype. It's not super interesting in this case because it's all numeric, and so forth. But if you had factors, that would go in here. And of course, where the real business happens, the predict endpoint. So here I can, let's say these emails were just half $signs and exclamation points. We would say, yes, that one is spam. And let's say we had another one. Let's say I wrote an email to someone and I used some capital all caps to tell people exciting things, but I didn't use any $signs. I did use, let's make this like this. It's a 10th capital letters. I used some I used some explanation points. I didn't have any money things, but I did use the word make like that. So if I try that, it says that one's not spam. So this is how our model can take and return predictions deployed as an API.
All right, we did it. I think that's a pretty interesting result in that in this particular case, we see that tuning the random forest doesn't really, we don't see a lot of benefit. That it actually is common for random forests, for many different sizes of data sets where you might use a random forest. Complexity, you don't really gain much by tuning random forests as long as you have enough trees, though we set the trees high enough. We used workflow sets to try quite a number, and it's a great tool for when you are in a situation where that is an appropriate thing to do. So I think that's it for today. I hope this was helpful, and I'll see you next time.